Okay, the next part of differentiation is something called the chain rule. Now that's when we're trying to differentiate a function within a function. So the chain rule just says, if I've got a function u and another function f, I differentiate u, differentiate f, multiply them together. Now, this will make more sense when you look at the examples. So if you look at this first one, to differentiate that, you could expand the bracket and then differentiate the term, but that's going to be a lot of work. However, using the chain rule, what we can do is we can spot that really it's a function in the function. So my first function is the bracket, and it's that thing to the power 7. So I'm going to call the bracket u, so 3x squared plus 5x plus 2. And if that's u, then my function now just looks like y equals u to the power 7. So the chain rule says what I can now do is I can differentiate both of them. So if I differentiate u by x, I get 6x plus 5. And if I differentiate y by u, I get 7u6. And then the chain rule says to get dy by dx, I multiply them together. So I do du by dx times dy by du. And what's kind of happening here is these du's are cancelling out, just leaving me with dy by dx. So I get 6x plus 5 times 7u6. Well, all I need to do now is sub back in what u is. I'm going to write my number at the front, then my easy bracket, and then I'm going to write what u is. So 3x squared plus 5x plus 2 to the power 6. Yeah, it looks complicated, but once you've done a bit of practice, it becomes really quick. So the second one, my u, again, I've got a function in a function. My first function is 3x, and I'm subbing that in sine. So 3x is my function, so I'm going to call that u is 3x. Then if that's what u is, then my y becomes sine u. Now I can differentiate them both separately now. So du by dx gives me just 3. And dy by du, well, sine u, if I differentiate sine, I get cos, that's just cos u. The chain rule says multiply them together. So dy by dx, I get du by dx times dy by du. So that gives me 3 times cos u. And again, just sub back in what u was. So it's 3 cos 3x. And the final one, well, this one, I haven't got any brackets. However, when I've got a power, I've got invisible brackets around the x squared. So my x squared there is going to be my u. And if that's my u, then my y just becomes e to the power u. Differentiate them both separately. So du by dx is 2x. dy by du is e to the u, because e doesn't change. And then use the chain rule, so dy by dx is du by dx times dy by du. So I get 2x times e to the u. Then again, just sub back in what u was. So 2x e to the x squared. That's it. Okay, a few more. So ln x squared. Well, with this one, my u is x squared. So then my y for this bit would just be ln u. So what I'm going to do is I'm going to separate them. So I'm going to do this bit and this bit separately. So I'm going to differentiate them both. So du by dx is 3x squared. Dy by du is, well, ln differentiates to 1 over, so ln x is 1 over x, so ln u is 1 over u. Then the chain rule says multiply them together. So I get 3x squared times 1 over u, so 1 over x cubed. Simplify that, and I just get, well, the x squared cancels out, so I get 3 over x. Okay, then do the same for this bit. So my u for this bit is going to be 7x. So du by dx is 7. And in that case, my y would be ln u, which we know that dy by du would be 1 over u. Times them together. So dy by dx for this one would be 7 times 1 over u, so 1 over 7x. And the 7s will cancel out, so just get 1 over x. So my final answer, dy by dx is, well, my answer for the first bit was 3 over x, plus my answer for the second bit was 1 over x, and I can simplify that to 4 over x. Okay, the second one. Before I use the chain rule, because I can't use it how it's written, I need to simplify each term. So I'm going to write it as 2 over 4e3x, take away 3e7x over 4e3x. Then the first one, 2 over 4 becomes a half, and this becomes a negative power. This one, 3 over 4, take away the power, so it's 7x, take away 3x is 4x. And then you would use the chain rule on each one separately. So on this one, my u would be minus 3x. And this one, my u would be 4x. When I differentiate it, I'm going to use sloppy notation now. I'm going to use just the dash notation. It's really sloppy because I shouldn't use that because I've got lots of different variables. Here I get minus 3. Here I would get 4. So when I would differentiate this thing, because this thing is now just a half e to the u, well, that differentiates to, if I call that y, then my y dash would be half e u. Then this bit here, my y would be 3 over 4 e to the u, because the u and this one is 4x. So my y dash is 3 over 4 e to the u. And then to differentiate the whole thing, well, I times these two together. So minus 3 times a half is minus 3 over 2. E to the u is e to the minus 3x. Take away, and I times these two things together now. So 4 times 3 over 4 gives me 3. E to the u, and u was 4x for this one. See, oh, this one, it's clear u in this one. So u is just 3x squared plus 5. So differentiate that and get 6x. So my y is now ln u, which differentiates to 1 over u. Multiply them together. So it's the two dashes and times them together. So it's 6x times 1 over u. So 1 over 3x squared plus 5, which gives me 6x over 3x squared plus 5.